let us understand the value of Trusteer, IBM's new security acquisition. And it all has to do with how to deal with malware at the endpoint. Whether the endpoint is a desktop or a mobile device, it works the same, but you need some assistance at the endpoint to deal with this. So, but what are the main things that people do, or they try to do when they put malware on your machine? The first one is to try to steal and use your credentials to impersonate you and to, get money out. How do they get that? Well, they get that typically by all sort of phishing attacks, and we're not going to talk about them in here. Second thing they try to do is they try to alter the transaction between the user and the bank or the party to commit fraud, and this actually defeats security tokens and second factor, because they make you believe that you are doing something, and in reality they alter the transaction to do something else. This is what Trojans, man in the middle, man in the browser, do. But before we move on, let's get an important context of where this is happening. About 90% of all the malware attacks happen on Java, or whether it's on the browser or running native. Most of them on the browser, but in both cases. So 90% goes to that. Just 2% these days goes to Adobe. It used to be much higher, but Adobe has done a good job in sandboxing their application. And the rest goes to Microsoft, Office, plugins, and others, right? So we understand the nature. Most of the stuff is around Java, and in fact people joke that Java stands for just another vulnerability announcement. So one of the things that people have been doing to defend themselves against these type of attacks. But number one, they've been trying to do blacklisting. So these things, I'm not going to let them run on my machine. And that's what antivirus do. Well, we know how ineffective antivirus are, because viruses tend to mutate. Then antivirus is like going today to a modern battlefield with a bow and arrow. It doesn't do the job anymore. Second approach that people do is sandboxing. And this is to allow the application to only do certain things within the sandbox. The problem is that most malware has figured out ways to escape from sandboxing, particularly in Java. And the main reason is there are so very many Microsoft kernel flaws that even on fonts, by rendering a font, they can get access to the kernel. So with so many holes in there, this approach doesn't always work. Another type is to look at the behavior of the user and stop bad behavior. And this is the approach, like for example FireEye uses. The problem with that is that you need to know what are the threats. You can be patient zero here, and this type of technology won't help you. Here's another approach that some people have tried to do is application whitelisting. So I'm gonna only allow these particular apps to run on my environment. Well, this is very difficult, costly to implement, because unless you are in retail where all the machines are exactly the same, then the combination of application DLLs and machines, make it impossible to implement. So those things are our approach. What Trusteer brings is a new and very clever idea. It's called application, here's the key word, stateful whitelisting. Meaning, I'm going to look for only valid states of the application, and those are the ones that I'm going to allow. But also does a very good job in protecting you against credential stealing. So it's going to do a very effective credential protection. It has two components, as you may guess by now. One has to run on the actual desktop, and there's another component that runs on the server. Okay. So on the desktop, it actually, let's depict here, you know, the operating system. So we have here Windows or Mac. It works for both. So we have here the OS. And next you have the actual API, where application get services from the OS. And our technology sits right here. Let's put it here. It's in the form of report for financial application and Apex. And we'll see many of the things that it can do, but let's start with the most simple one and the most effective one. In fact, you'll be by the end of the video, I hope that you will be inclined to actually try this. It's actually free, this component, and download report for testing. So it's going to protect your credentials. So what bad people do with all these phishing attempts and, you know, all the different attacks is to lure you to go into an URL that you think it is the appropriate, the valid URL, but in reality is something that the bad guy actually did for you. So let's say that you have some sort of a malware on your machine, and that malware is going to lure you with the wrong URL. Well, what Rapport and Apex do is that they have a secure DNS service that the client will invoke. It will not use the DNS that is on the machine, but this secure DNS server when you go to that particular site. And it's going to get the right IP addresses for that. So no way that malware can defeat that. And it will warn you in case that you are trying to inject a credential like a password into a site that is not what you think it is. You've been phished. You're going to a site that you think it is. Rapport knows better, and it's going to tell you, pal, you sure you want to do that? Because that is not the site that you want to do. So that's a very effective way of protecting your credentials. But the other thing that it does, and is very effective in this, it actually allows bad APIs for invoking making an effective API call. How does that work? How does Rapport or Apex know what applications are good, that they should be allowed? So these are good API calls, and I'm going to allow them, and when. It's the key part. And which API calls are actually bad. So I can stop them. So it's going to do that right now in the context of all Java, Adobe, Flash and Acrobat, and Microsoft Office applications and attachments, right? So what are some of the examples of the things that applications do, the different states that they can be on? For example, 1B at one point could be writing to a file. This can be good or bad, depends on what application and where is the application actually doing that. Another one could be adding, say, a new payee. And let's say that you are outside the country that you have the account set out, say US. Another one that is always bad is initiating command and control communication. Let's say that it's opening an RC traffic to talk to the bot master. Another bad example, it's firing up a keylogger. Why is a call to services that are used by keyloggers or screen capture? Another example would be writing to some very sensitive, specific registry keys in Windows. So the Windows registry, there are some keys. Why is the application trying to do that? Another one could be invoking a remote access tool. You get the picture, etc. So what Trusteer is capable of doing is actually knowing all the different states that the application can actually go, and that's how we set them up. So if it sees that you're trying to go to a state that is not allowed, from that sequence of events, and that's what the stateful is, it can actually block that call. It's very effective, and this approach actually yields virtually zero false positive. And the other thing that it does is provides actionable intelligence. Well, let's say that, and this is just a very basic example, that the client here on a browser, or or the desktop application, it's invoking an API, or for example, let's make it simple. Let's say it's trying to, the user has been lured into going to a phishing site. Regardless of that, the user goes ahead and sends his credentials into the bad site. Well, the client communicates with the server, and now the server is warned about that fact. So let's say that a hacker, they see that from a different IP address, different country, etc. Somebody is trying to use the right credentials to access a site. A report can actually block that attempt because of the combination of the information that it got from the desktop. Very effective technology. I encourage you to download Rapport and try it.